So just to clarify, everyone can see my screen, right? I hope that it is visible to everyone. So our lesson today is free and open source of. Actually, our subject is free and open source software for personal computing. And if you can remember, in during the in-class sessions, we have conducted uh, sessions related to LibreOffice and GIMP, and also including within the LibreOffice. Actually, we covered the spreadsheet management and then word processing, database management, and also presentation design. So those parts were covered during the in-class sessions, and finally, as an online session, we conducted the lesson related to GIMP, where we design some, we work with images and manipulated images and edited images, and we did stuff like that. And I think if I'm correct, we did the database management part also as an online session. So yeah, if that is correct, actually, those videos must be available in the Google Classroom as separately uploaded videos, and also probably in the YouTube channel as well. So in this session, actually, I'm going to focus on this lesson one of this free and open source software for personal computing. And in this case, actually, in during the in-class session, I have already covered this one. This presentation I have already covered in during the in-class sessions. So I'm going to repeat it so that you can get a better understanding of you know the concepts related to free and open source software. And after that, I'm going to guide you through the installation of Ubuntu operating system, and then work with files within the Ubuntu operating system. So that is a part of the syllabus that we have to follow. So that will be what I'm going to do today, and let's see what we can do. So this is going to be a short session, so it's not a very difficult one, but I highly encourage you to, or I highly urge you to please go through these slides and do the installation yourself. I will get back to it once I do the installation. So for the moment, let's start with this unit and see what we can do. So first of all, we have, so our unit, our subject is free and open source software for personal computing. So that gives us the problem, what is a software? So based on this topic, you can ask yourself the question, what is a software? And personal computing is using the computer or computing capabilities for your own personal needs. So that is what personal computing means. And then we have several keywords here that we need to understand before moving forward. So we are learning about free and open source software. Then you have to ask yourself the question, what is a software? And then you have to ask yourself the question, what does it mean by free and open source? So these three keywords are what you need to understand and focus. And even in the examination, you might be tested by getting asked about these keywords or software, or whatever it is that is relevant to this particular subject. Okay. So introduction to FOSS. We also call it FOSS. Okay. FOSS. FOSS stands for free and open source software. So FOSS stands for free and open source software. Right. Introduction to FOSS. So in this part, actually, let's go through this lesson first. Yeah. In this unit, in this lesson, actually, we have two major parts. The first one is introduction to major software classification, and the second one is introduction to free and open source software. So the second section answers our question, what it means by free and open source software. And in the first one, it will probably answer our question, what it means, or what it is meant by software. Okay. So first part is introduction to major software classification. Major software classification. Oh, what does it mean by classification? මොන හරි දෙයක් classify කරනවා කියන්නේ මොකක්ද? What do you mean by classification? මොන හරි දෙයක් කැටගරිකල් විදියට තියෙනවා. ඒ කියන්නේ මොන හරි දෙයක් කොටස් වලට වෙන් කරනවා වගේ දෙයක් තමයි ක්ලාසිෆිකේෂන් එකේදී කියලා කියන්නේ. අපි හිතමු ක්‍රිකට් ටීම් එකක් මැච් එකක් නම් මැච් එකක එන්න පුළුවන් අවුට්කම්ස් මොනවද? එක්කෝ දිනනවා. If you consider a particular team, for example, today's game, England, there were three possible results. One was England winning, or one was England losing, and the other result is England drawing the match. So those are the three results, and those three results are categorical variables. Uh, so that is what you mean. So you can basically classify the outcome to three particular groups. So that is what we are going to. We are going to classify the types of software into two particular groups. So that is why, and what we do with software classification. So before going on to that, we have to ask ourselves the question, what is a software? This is the same question that I asked you earlier. So what is a software? A set of instructions or programs instructing a computer to do specific tasks. A set of instructions or programs instructing a computer to do specific tasks. ඔයා මොනා හරි ඉන්ස්ට්‍රක්ෂන් සෙට් එකක් ලියනවා කෝඩ් කරනවා හෝ මොනා හරි කෝඩ් කරනවා කියලා කියමු ඔයා ඉන්ස්ට්‍රක්ෂන් සෙට් එකක් ලියනවා ඒක කම්පියුටර් එකට ඉන්ස්ට්‍රක්ට් කරනවා මෙන්න මේ විදිහට කරන්න කියලා. එතකොට කම්පියුටර් එකෙන් ඒක කරනවා නම් ඒක software එකක්. අපි කරන්නේ අතන instructions දෙන එක තමයි. Software consists of the computer programs that govern the operations of the computer. Software consists of the computer programs that govern the operations of the computer. So you program it to do something, and it software actually consists of those, your little programs, and those programs will run according to your instructions. Therefore the softwares will run on the computer and give you the necessary outcome that you wish. Okay, so it also gives the computer the power to act as an intelligent machine. It gives the computer to power it gives the computer the power to act as an intelligent machine. So rather than just doing anything, it just, we can instruct it to do something intelligent, or we can instruct it to be intelligent. So that is what we can do with software. And without software, computers are dead hardware. So now we have another keyword, hardware. So what does it mean by hardware in computers? Hardware are, components in the computer which are touch and tangible. You can touch the hardware. Now for example, if you take a computer system, the most obvious part is the monitor. The monitor is the output device which displays whatever that you wish to see, right? So there is a monitor. So monitor is touchable and tangible, right? We can touch the monitor. අපිට අල්ලන්න පුළුවන් මොකක් හරි කියන ඕන දෙයක් අල්ලන්න පුළුවන්. ඊළඟට කම්පියුටර් එකක් ගත්තොත් ඒක ඇතුලේ RAM එකක් තියෙනවා, processor එකක් තියෙනවා, hard disk එකක් තියෙනවා, වටේ casing එක තියෙනවා, ඇතුලේ DVD writer, ඒ වගේ components තියෙන්න පුළුවන්. ඒ හැම දෙයක්ම you can touch all of them. So those things which can be touched and which are tangible are called computer hardware. So now if there is, just the hardware, so if you have just the hard disk and the DVD writer and processor and everything, there is නිකන් තියෙනවා වැඩක් නැහැ. වැඩක් තියෙනවද එහෙම නිකන් තිබිලා නෑනේ. නිකන් අපිට වැඩක් වෙන්නේ නෑනේ. So you need to make sure that those hardware items are usable, right? Without software, computers are dead hardware. So if you do not have the software to run the hardware, if you do not have the software to make use of the hardware, then that is actually a dead hardware, right? So that is why softwares are very important. Actually what happens is that the hardwares are basically unusable without software, right? And then so those two things go, like then නැතුව බෑ software For software to run, it needs hardware, and for hardware to be usable, it needs software. So those two components are really important in order to have a usable system for everyone that is using the computer. Okay, so software is normally classified into two components. So now we know what a software is. Now we are going to classify the software into two components, right? So now we are going to do the classification. As I said, software can be classified into two components known as application software and system software. Application software and system software. So these are the sort of questions, or these are the sort of topics that might be asked in the examination. So please make sure that you go through these notes and listen to what I'm saying. Okay, so application software and system software are the two components that are available in the classification of softwares. So first one is application software. So what does it mean by an application software? An application software is a set of programs designed to carry out operations for a specified purpose or task. An application software is a set of programs, or set of instructions designed to carry out operations for a specified purpose or task. So basically, the application softwares make sure that specific tasks or purposes are accomplished, right? For example, we have packaged applications like Microsoft Office or the LibreOffice, which we've been doing for the past year. And then there are accounting applications, web browsers like Google Chrome, or even this PDF reader, Foxit PDF reader. It's also an application software. Then there are photo editors, GIMP, Adobe Photoshop. Softwares like that, though, that are called application softwares, and also systems developed according to user requirements, bespoke softwares. So systems developed according to user requirements. That means probably know that in your third year of study you have the third year final year project, and in that project actually you have to build a software to a particular client, and you are making sure that the software is meeting the requirements of the client, right? So you are making a customized application according to the user requirements. So basically you will be developing a bespoke software, and eventually what you will be building is an application software, right? So that is what you need to keep in your mind. So an application software is a set of programs designed to carry out operations for a specified purpose or task. So basically, if you are developing a desktop application for a client, then it will be an application software, right? Uh, so yeah, I was talking about the desktop application, right? Then we have the system softwares. System software. So first in the classification, the first one was application software, and the other one is system software. Now we have to discuss about the system software. Application software cannot run without having system software. So I initially told you that hardware items are unusable without software, and then I spoke about application software. Now we say that the application software cannot run without having system software. So basically, in order for the hardware to be usable, we need to have system software, and then in order for the application softwares to be usable, we need to have system software, right? I think you can see the connection there. So application software cannot run without having system software, and hardware devices together with system software. Hardware devices together with system software. So at the bottom of the stack, you have the hardware, and on top of that, you have the system software, and on top of that, you have the application software. Hardware devices together with system software provide the infrastructure to run, execute application software, right? Hardware devices together with system software provide the infrastructure to run or execute application software. And system software acts as an interface between the hardware of the computer and the application software. So system software is what bridges the gap between the hardware and the application software, right? So in one side you have the application software, and the other side you have hardware. And let's say if you have Microsoft Office, you need to run it somewhere, right? So you cannot directly run the Microsoft Office on hardware. You can only run it on a system software, and system software will make sure that it has the relevant communication with the hardware. So those three components work together. What are the components? Hardware, system software, and application software. So system software communicates with hardware devices. System software communicates with hardware devices to coordinate activities. So system software is what that basically or directly communicates with the hardware devices to make sure that the hardware devices are usable. The examples are the operating system. Now imagine the scenario: you have Microsoft Office, right? Can you run Microsoft Office directly on any hardware? No, you have to first have an operating system, and then you have to run the Microsoft Office application on top of that operating system, right? I hope you get the idea. So operating systems, for example, we can give Microsoft Windows, Linux, Unix, Mac OS, DOS, etc. Right? So there are many operating systems, and most of them, there are many distributions of Linux as well. So operating systems are what that directly communicate with the hardware to give you a usable computer system. So then there are also utility softwares. For example, softwares that or device driver softwares can be considered as that directly communicate with the hardware. And then there are language translators, assemblers, compilers, interpreters. So those are what you have probably learned about compilers and interpreters, like that. So there are differences between system software and application software. So this table summarizes the differences between the application software and system software. So system software is used for operating computer hardware, and system software is installed on computer when operating system is installed. See, well, system software itself can be an operating system itself is an system software. So this is probably talking about the other sorts of system software. The user does not interact with the software. This is also speaking about the sorts of sort of system softwares that that work on top of the operating systems, and it provides a platform for running application software. Definitely it provides a platform for running application software. And then there are application softwares, and application softwares are used by user to perform specific tasks. So now if you take Adobe Photoshop, you use it for manipulating images or for editing images or working with images basically. So that is its specific task. It works with images, and you are using Adobe Photoshop or even GIMP for working with images. And if you want to create a document, you use a word processor like Microsoft Word, or uh, if you want to work with spreadsheets, you can use Microsoft Excel or LibreOffice Calc. No, there are specific softwares which can be used depending on the user requirement. So installed according to user requirements. The user interacts with application software. Yes, the application software cannot run without the presence of system software. So that is what I explained earlier as well. The application software cannot run without the presence of system software. So here's a little diagram. At the bottom you have the hardware: CPU, disk, mouse, printer, all those hardware, touch and tangible things. Then on top of that you have the system softwares, operating systems, and the utility softwares, softwares like that. And on top of that you have the application softwares, the spreadsheet management softwares, games, word processors, browsers, databases, all those utility softwares, or not the utility software, all those application softwares, all work on top of the system softwares. Okay, now so that is what that actually covers the meaning of, or the classification of softwares. Now moving on to the next session, we have Introduction to Free and Open Source Software, FOSS. So what is free and open source software? So what does it mean by free and open source? So this term, the term FOSS, depends on two major philosophies. The first one is Free Software Foundation philosophy, and the other one is the Open Source Initiative philosophy. Those are two philosophies, and you might probably be asked about these two philosophies, not in deep, but you might be asked what the philosophies are. Or, I don't know, but just note them. An umbrella term used for software that is considered both free software and open source software. So yeah, free and open source software is an umbrella term, or is a collective term, combined term that you can use for uh, describing both free software and the open source software. So I spoke about two philosophies. First one is Free Software Foundation philosophy. So it means that softwares are free, right? Free softwares. Computer software distributed under terms that allow users to run the software for any purpose, as well as to study, change, distribute it, or any adapted versions, right? Computer software distributed under terms that allow users to run the software for any purpose. You can run it for any purpose you want. If you want, now for example, uh, if you take a free software, you should be able to run it for any purpose you wish, right? You should be able to change it, and you should be able to distribute it, or distribute an adapted version without any restrictions. That means it is free. They give you the authority to do, to work with it, change it, distribute it, or do stuff like that, right? So that is what is meant by free software. And at the same time, it protects four user freedoms, right? Four user freedoms. The four user freedoms are the freedom to run a program for any purpose. Yeah, so that is what I meant earlier. You should be able to run the program for any purpose. And the freedom to study how a program works and adapt it to a person's needs. Access to the source code is a precondition for this, definitely. So you should be able to study how that program works. So that is a characteristic of this free and open source software. And for that, actually, you need to be able to access the source code of the software, right? In order to study how a program works. And then there's another freedom, the freedom to distribute copies so that you can help your neighbor. Now imagine one of your neighbors ask you to create a particular software, and you find that there is an open source, or a for software that might be suitable for your neighbor's requirements. But at the same time, your neighbor's requirements might be little bit different from what that software box offers out of the box, right? So in that case, if that software gives you the ability to you know study it and change it, or this, right, change it, or do whatever you want with the software, then you should be able to do that, right? If it is a free and open source software. So that is what is meant by that. And that means you should be able to redistribute the copy of that software. Now say that neighbor wants you to suggest a software, and you know that there is this software which is open source and free, and then you should be able to give it to your neighbor without any restrictions. And even if you want to modify its source code and change it according to his requirements, then also it should be possible. The freedom to improve a program, release or improvements to the public, so that the whole community benefits. So that is what I meant earlier. Access to the source code is a precondition for this. So those are the four freedoms that comes with the Free Software Foundation philosophy. The freedom to run a program for any purpose. You should be able to run the program for any purpose. The freedom to study how a program works and adapt it to a person's needs. That means you should be able to study it and make modifications according to your requirements. And then you should be able to give it to, or redistribute, or give the software to anyone else without any restriction. Now, for example, if you have Microsoft Office with yourself, a genuine copy, right? If you have a Microsoft Office, a genuine copy with yourself, a paid copy, its license does not allow you to, since its license most probably does not allow you to give it to someone else, right? So that means it is not an free and open source software because its license does not allow you to distribute it. But with open source and free software, what you can do is you can distribute it or redistribute it to anyone else without any restriction. And then the freedom to improve a program and release the improvements to the public. That means that is how the open source community works. The software, it should have, or it should give you the freedom to improve the software according to customization requirements or whatever the requirements are, and then apply that, and then offer the software to the community so that the community can benefit from your changes. For the last three freedom points or freedoms, actually you need to have the access to the open source or the source code. Then there is open source initiative philosophy. A type of What is an open source software? A type of computer software in which source code is released under a license in which the copyright holder grants users the rights to study, change, and distribute the software to anyone and for any purpose. So this is basically covered by the freedoms given in that previous philosophy. A type of computer software in which the source code is released under a license. So the source code is there and it has been released under a license, and that license allows you to study it or change it or distribute the software to anyone else without any restrictions, right? So that is what is meant by the open source software. And open source software may be developed in a collaborative public manner. Open source software may be developed in a collaborative public manner. So if you go to GitHub, or there are many open source frameworks available in even in GitHub or Bitbucket, there are repositories, so you can obviously contribute to them, because open source softwares are built by the public for the public, right? So you can obviously contribute to them even if you are creating a minor bug fix, or even a documentation contribution. That also counts as a contribution. So it's important that you contribute to open source software to help the public. And when programmers can redistribute and modify the source code for a piece of software, the software evolves. Definitely it should happen. That means the community contributes towards the software, and gradually the software gets evolved in a positive manner, and people improve it, people adapt it, and people fix bugs. So that is a combined effort by the community. So there are free and open source software examples. So what are the examples? There are GNU Linux operating systems. Linux based operating systems are mostly open source, and then LibreOffice, OpenOffice, GIMP, MySQL, PHP, Eclipse. Those are free and open source softwares and languages, and those can be considered as free and open source examples. Microsoft Office is never an example. Adobe Photoshop is not an example, right? So that is why in this course we are focusing only on using free and open source softwares. For example, we are using LibreOffice, so we are using GIMP, uh, like that. Then there are pros and cons. So pros are advantages and cons are disadvantages. So what are the advantages or benefits of FOSS? With FOSS, there is no cost, or always cheaper than proprietary software. Proprietary software are softwares like Adobe Photoshop or Microsoft Office. And then there is higher increased security because the community contributes towards it, and then the security is always up to date. They always make sure that the security of the software is maintained at higher levels in order to protect the security and privacy and everything. So availability of source code. The source code is available in free and open source software, and then there and open standards and vendor independence is also there. That means open standards are followed. There are standards which are open, and then standards, there is always a common standard which is followed by the community when developing such software. So it's obviously a benefit. And then vendor independence. That means it does not depend on several vendors. For example, uh, let's say a proprietary software develops a particular standard, and then what happens is that uh, other parties may have to pay that particular vendor in order to use their own software system or whatever the innovation that they have brought on. So but with free and open source softwares, it does not happen like that, because everything is open source and free. So there is no, or it does not have to depend on vendors for developing software. And then there are limitations as well. Lack of compatibility with proprietary systems. Obviously it can happen, lack of compatibility with proprietary systems. Now for example, actually now this limitation has mostly been addressed, because most of the open source softwares are developed for, you know, developed to be compatible with multiple operating systems. And the yeah, it has been addressed in terms of operating systems, but there can be compatibility issues with proprietary systems, right? I think in the past LibreOffice did not support, I'm not sure about this, but in the past I think LibreOffice did not support docx, or the files of Microsoft Office. And now I think it supports. So there can be issues like that, right? Then lack of extensive documentation. So what happens with proprietary software is that, you know, they invest large sums of money for creating proprietary software, but with open source softwares, no one is in, no, usually uh, usually what happens is the investments can be low, right? In that case, the community itself is that has to contribute towards the documentation preparation and everything regarding the software. So the documentation part can at times, you know, get fuzzy and, you know, not up to the standards which is depicted in other proprietary software. So it can be a limitation, right? So that is why I said that even if you can contribute towards the documentation of an open source software, it's also worth an effort, right? So what is proprietary software? Now I've been talking about the proprietary software, but I did not explain what it is. uh, okay, so right, proprietary software, the software that is solely owned by the individual or the organization that developed it. Now again, for example, Microsoft Office application package belongs to Microsoft, right? So they solely own the software, and they are the ones who develop and support that. Then the source code can only be modified by the individual or the organization who created it, because it is not open source. The code is available only to the developers who are working within that organization. Therefore, the source code can only be modified by the developers who are working within that organization. The owner or publisher of the software holds intellectual property rights of the source code exclusively. They are the ones who are holding the intellectual property rights, right? So there can be legal issues if you try to play with the source code of that of those proprietary software. Even if it is not available, you know, whether you hack it or, you know, there can be problems. The internal structure of proprietary software is not exposed, right? And the restrictions are imposed upon these users by the end user license agreement. So this is possibly something that you never read when installing a software, but what happens is proprietary software are that, you know, whenever you install a software, there is this, you know, big essay like thing that you almost never read, right? I know that because that is something that no one does. but in that end user license agreement there are many legal aspects that protects them and makes you guilty if you are doing anything wrong with their software. So uh, actually what happens is we usually agree to that end user license agreement before installing a software. So that license agreement, uh, those restrictions are imposed upon the users by the end user license agreement, right? Then the examples are Windows, Microsoft Windows, Mac OS, Google Earth, Adobe Flash Player, Microsoft Office. So those can be considered as proprietary software examples. In this actually lecture note, there is an activity: compare and contrast FOSS and proprietary software. Find more examples of FOSS and proprietary software. Is Google Docs an example for FOSS? Justify your answer. Is it an is it a free and open source software? Is Google Docs an example for FOSS? Can you give me the answer? Google Docs is free. You can obviously use it for free of charge, but it's open source is not available online for you to those for you to study the code or manage it or redistribute it. So that is not available with Google Docs. Therefore, Google Docs is not an example for free and open source software. It is free, but don't confuse it with the open source requirement, right? Uh, then there is a summary, introduction to major software classification. I spoke about different types of softwares. What are the different types of softwares? So system softwares and application softwares, and then we distinguish the differences between the application softwares and system softwares. Next, we discussed what actually free and open source software means, right? Then we distinguish the differences between open source softwares and proprietary softwares. And finally, we identify different types of free and open source software. So that basically sums up this lesson. And I am again telling you this is a lesson that I uh, taught you about a year ago as an in-class session. So this is more of a recap, and I hope you got the idea regarding this particular lesson. So the next part of this lesson focuses on actually uh, installation of a free and open source software. So I'm going to play a little video. So in this video I'll be guiding you through how I installed or how to install the Ubuntu operating system in your computer, right? So as I said in the previous example, the Linux distributions can be considered as most of the Linux distributions can be considered as free and open source software. And then Ubuntu is one such example, which is obviously free. And in this video I'm going to show how we can install Ubuntu operating system in a VirtualBox. Right? So what is a VirtualBox? VirtualBox is a powerful x86 and AMD 64 Intel system virtualization product for enterprise as well as home use, right? So it is a virtualization product, right? And it actually VirtualBox is available in it's cross platform. That means it is available in Windows and Linux and Mac OS on any operating system that is basically widely available. You can install VirtualBox on top of that operating system. And VirtualBox is more like a think of it as a box. නිකන් operating system එකේ තව software එකක් හදනවා box එකක් වගේ. ඒ box එක ඇතුලේ ඔයාලට පුළුවන් operating system එකක් install කරන්න. එහෙම නිකන් අර computer එක ඇතුලේ තව computer එකක් හදනවා වගේ වැඩක් තමයි මේක කරන්නේ. එතකොට අපි කරන්නේ VirtualBox එක install කරනවා. VirtualBox එක කියන්නේ අලුතෙන් ඔයා computer එකක් ඇතුලේ install කරා වගේ තමයි. virtual computer එකක්. ඔයාලට පුළුවන් ඒ කම්පියුටර් එක ඇතුලේ තව operating system එකක් run කරන්න. Right, it can be installed in the existing computer so that another OS will run inside the virtualbox. Okay, so yeah, I'm going to first download the virtualbox, and virtualbox is available in virtualbox.org website. So yeah, first go to that website and click download virtualbox. Then as I said, this is available on cross platform. That means it is available for Windows, OS 10, that is Mac, and Linux distributions, and Solaris distributions, right? So I'm using Windows here, so I'm going to download the VirtualBox package, which is compatible with Microsoft Windows, right? And I'm talking about this Oracle VirtualBox. So VirtualBox is offered by Oracle, and it's a free and open source software which is used for virtualization, and it is developed by Oracle, right? So as I said, first you have to download the VirtualBox, and then I'm going to install Ubuntu as an operating system inside VirtualBox. So for that, actually you need to download Ubuntu as well. So Ubuntu is also, as I said, another operating system, and to download Ubuntu, first you have to go to ubuntu.com and click download, and I'm going to download a desktop version. Ubuntu is available for IoT, cloud, servers, and desktop, and since I'm going to use it for usual task, I'm going to download the desktop version, and make sure that you download the version having this LTS stands for long term support. That means support, or the community support, or the support, basically support is available uh, in the long term for 20.04 version, and in a while it starts downloading. So just download the image file, the ISO file, and obviously it will take some time depending on the internet connection speed you have. So it's 2.6 GB, and once it is downloaded, you have those two files here, right? The Ubuntu file and the VirtualBox. Now I'm going to install the VirtualBox. So when you run the VirtualBox application, there are, it's the usual installation process, and just follow along the installation, and then it will install in a while. So I'm going to run Oracle just after the installation, Oracle VirtualBox. So this is the Oracle VirtualBox, right? So as I said, now Oracle VirtualBox runs on top of the Windows operating system, and you can install any number of operating systems here, right? Whenever you install an operating system inside VirtualBox, it will appear here as a list. They will appear here as a list. So now, since no operating system has been installed within this VirtualBox, no operating system appears here, but after I do the installation, one will appear here. Now I'm going to start or install the operating system here. First you have to click this new button, right? By clicking the new button, you have to click this new button, and once you click this new button, this menu will pop up. Here just write the name. I'm going to name it Ubuntu, and specify a machine folder within your computer. So that machine folder will be considered as the, when we install an operating system, අපි hard එකට install කරන්නේ. අපි hard එකට normal hard disk එකේ C drive එකට හරි කොහෙට හරි install කරන්නේ මේ operating system එක. ඒ වගේ මේ අපි ඉන්ස්ටෝල් කරන කෙනට එයාට දෙන්න ඕනේ අපි මෙන්න මේක තමයි hard disk එක කියලා අපේ ඇත්ත machine එකේ folder එකක් දෙන්න ඕනේ. So that is the role played by this machine folder. You have to specify a folder in which the operating system will be installed, and then you have to specify the type of the operating system, and as we know it's a Linux one, and the version will be Ubuntu 64-bit, right? Then you can specify the amount of RAM that you are going to allocate from your actual RAM. Now in this computer there is a memory capacity of 16 GB, therefore you can see that there are 16,384 MB, and I'm going to assign just 2 GB of that 16 GB memory to this virtual machine, so that this virtual machine will take up 2 GB of your RAM, right? So make sure that depending on your computer, uh, allocate an appropriate memory size for your virtual machine. I'm going to create a virtual hard disk now. Those settings are default settings, and just click create. You might also get the guided mode, and guided mode is also pretty easy. And then once you click create, then it asks you to create a hard disk for your virtual computer. As I said, this is the computer, this is the machine folder which you use, and then it asks about ask us how many gigabytes you want for your virtual machine. So I'm going to set it to 50 GB, I think. uh, yeah, 50 GB, and the other settings can be set can be kept as default, and click create. And actually there was an option here, storage on physical hard disk, dynamically allocated or fixed size. That means if you click fixed size, that means just 50 GB will be allocated, but if you allocate dynamically allocated, it will be like scalable and elastic. The more you need space, it will go up according to the requirements, right? So I'm going to select it as it is, and now the virtual machine was created inside Virtualbox. Now we have to install the operating system here, right? So it's just there, but no operating system has still been installed, even though the computer is there. Now this is the virtual computer. Think of it like a virtual computer. The computer is there, but මෙහෙම හිතන්නකෝ අලුතෙම කම්පියුටර් එකක් ගෙනහම මේ මුකුත් නෑනේ කම්පියුටර් එකේ ඔපරේටින් සිස්ටම් එක මුකුත් නෑ කියලා හිතන්නකෝ. එතකොට මුකුත් ඇත්තටම නෑනේ ඒකේ. නිකන් අපි මුලින්ම එකට ඔපරේටින් සිස්ටම් එකක් දාන්න එපා අලුතෙන් කම්පියුටර් එකක් ගෙනහම. ඒ වගේ තමයි මෙතනත් මේ අපි අලුතෙම කම්පියුටර් එකක් ගෙනලා මෙතනට දැම්ම විතරයි දැන්. දැන් මේකට තාම මුකුත් ඔපරේටින් සිස්ටම් මුකුත් දාලා නෑ. මේ කම්පියුටර් එකේ 2GB RAM එකක් තියෙනවා, ඊළඟට 50GB hard disk එකක් තියෙනවා. අලුත්ම කම්පියුටර් එක. හැබැයි මුකුත් දාලා නෑ. දැන් අපි හදන්නේ මේකට කම්පියුටර් එකක් දාන්න, මේ ඔපරේටින් සිස්ටම් එකක් ඉන්ස්ටෝල් කරන්න තමයි යන්නේ. So for that, actually, you can configure several settings related to this particular virtual computer. You can give it a name or set storage and everything. And normally, අපි system අලුතෙන් operating system එකක් දානකොට මුලින්ම කරන්නේ එක්කෝ ඒ operating system එකේ image එක DVD එකකට write කරගන්නවා. DVD එක write කරලා DVD එක තමයි boot කරන්නේ මුලින්ම. සාමාන්‍යයෙන් operating system එකක් install කරනකොට ඒකයි කරන්නේ. එහෙම නැත්නම් දැන් නම් අලුත් computers වල නම් කරන්නේ අපිට පුළුවන් pen drive එකකට flash drive එකකට operating system එක write කරලා අපිට pen drive එකෙන් පුළුවන් boot කරන්න computer එක. හරිද? අපිට කැමති විදිහක් කරන්න පුළුවන්. හැබැයි දැන් මම මෙතන කරන්න යන්නේ. එතකොට මේක දැන් මම කියවනේ අලුත් computer එකක් වගේ කියලා. මෙතන අපිට පුළුවන් මේ IDE slot එකට දෙන්න IDE කියන එකට. දැන් empty නේ තියෙන්නේ. මට පුළුවන් මේකට දෙන්න අපේ අපි ගත්ත අර image එක තියෙන Ubuntu image එක image file එක ඒක CD එකක් වගේ තමයි act කරන්නේ. අපිට පුළුවන් එයාට මේ කෙලින්ම disk file එක දෙන්න. මම දැන් ඒක තමයි කරන්නේ. disk file එක දුන්නා. දැන් එතකොට මේක වෙන්නේ නිකන් අපි අලුත් computer එකක් ගෙනල්ලා ඒකේ DVD write එක computer එක on වෙද්දිම ඒක ඇතුළට Ubuntu write කරපු DVD එකක් දැම්ම වගේ වැඩක් තමයි දැන් වෙලා තියෙන්නේ. Right? Now I selected that and click OK. Right? දැන් අපි එතකොට මේ computer එක ඇතුළට Ubuntu එක දාලා තියෙනවා. මේ Ubuntu DVD එක දාලා තියෙන්නේ, right? And then again you can specify other settings. You know, initially we set 2048 MB as the RAM, and you can obviously go through these settings and adjust the settings according to your requirements. You can even set the number of CPUs per operating system and the execution cap, right? That is how much percentage of your CPU to consume for that can be consumed within this operating system, and then just finally click start. Now, as I said, we have already inserted the Ubuntu DVD. Now දැන් අපි මේ start කරාම අරක on එක තමයි වෙන්නේ. start කරානේ. start කරාම දැන් computer එක on වෙනවා. Now they are asking us to select startup disk. අපි computer එකෙත් අර BIOS වලින් ඔයගොල්ලෝ දන්නවා ඇති මේ install කරනකොට අපිට පුළුවන් first boot device එක මොකක්ද දාන්න කියලා බලන්න. ඔක hard disk එක දාන්න පුළුවන් නැත්නම් we can set up the DVD writer or the flash drive. So there is a boot order which you can select. So that is what now this is asking us to specify the first boot or the startup disk. So I'm going to set it as now, as I said, we selected we have already inserted the Ubuntu DVD now as an image, so I'm going to select that. Okay, click start. Now the system is starting. It will take a while, so you can switch to full screen if you want. It will take a while, then after a while actually this will come up. So this will be the installation. This will be the installation window. Okay, with Ubuntu actually there are two options that can be followed. First, we can use the try Ubuntu option, and then there is install Ubuntu option. So with try Ubuntu option, what happens is, you know, it just loads the operating system into RAM, possibly to RAM, and then it allows you to, you know, test the software, test whether it suits your requirements, or try it. Basically, you can basically try it, right, without installing. So it does not make any change just to your system. It just gives you the opportunity to try the software, right? So we can even, if you want, you can just try the Ubuntu, but then again, whenever you run it again, it won't come back again, right? But if you install Ubuntu, it will install, or it will get installed permanently on the computer, and you have to specify or allocate some space for it to run. So I'm going to install Ubuntu now. Also there are options, you know, to dual boot Ubuntu. That means you can run both Windows and Ubuntu operating system at the same time in the same computer, and whenever you you turn on your computer, it will ask which operating system to open up with. So in that menu you have to select either Ubuntu or operating or Windows operating system, or whatever the other operating system you have. So that is, you know, you can install actually multiple operating system, not only dual. You can install multiple operating systems, and in the installation process, you know, just the basic stuff are asked, you know, the language, and then it is asking us about this normal installation or minimal installation. That means only the web browser and basic utilities, but I have selected this normal installation because all, you know, all necessary and essential softwares are installed together with the operating system. So and I recommend you to tick this one, download updates while installing Ubuntu, but it will consume your data package. So make sure that you have enough data in your broadband package if you are going to do this. And then this ticking this one is also will be helpful. And this will definitely be helpful if you are going to install it directly on your computer rather than installing it on a virtual box. So yeah, these things actually will consume your data possibly, so be careful of that. And now click continue. Even without ticking them, it will install all right. It will take some time. Then the computer currently has no detected operating system. What would you like to do? Erase disk and install Ubuntu. So now we have 50 GB of disk space within this little computer now. So I'm going to erase disk and install Ubuntu, because Ubuntu is the only operating system which I'm going to install in this particular virtual machine, right? And yeah, if you are an advanced user, obviously you can click something else and you can do the resizing or the partitions yourself, or the you know play with the operating system partitions. And I please be careful with that, because if you don't do it right, there is a high possibility of getting your uh, data erased or data formatted. But I'm talking about installing it on directly on your computer. But if you are installing it on inside this virtual box, then there won't be any harm to your uh, there won't possibly be any harm to your files if you are doing it right. Okay, so the way I'm doing it right now, there won't be harm, but please be careful. Just install it inside the VM. Then before going ahead with formatting and pre-partitioning, it warns you that about the potential changes that it will take. The changes listed below will be written to the disk, otherwise you will be able to make further changes manually. So yeah, go ahead and continue. Again, please be careful with your data if you are going to install it directly on your computer. But with the virtual machine, there won't any be possibly any issues. Now you have to select the time zone, and you have to specify a name, password, just basic things. Okay, after including them or after writing them, click continue. Now it will take up some time, possibly half an hour or 1 hour. I'm not sure, depending on your computer specifications. It will take some time to install the uh, operating system, right? Once the installation is complete, it will ask you to restart now. Click restart now. Then it will restart, and then it asks us to remove the installation medium. And with VirtualBox, actually, I don't think you will have to do that, because I did not have to do any changes. Just waited and it restarted automatically, right? So now we created a user called test instance, and then it loads up, and all you have to do is just log in just like Windows. Then initially there will be this window where it's more of a wizard. Even after installing Windows, you get this kind of a wizard with Cortana in it. Just select the relevant settings and click next, 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 and done. Now you have the Ubuntu operating system inside the VirtualBox. You can just obviously set the resolution. Initially there won't be, the resolution might not match the native resolution of your monitor or the computer. So for that, actually there is an option I will tell you. Actually, just Google it and you will get the answer how to do it. Right, for the moment, this resolution will be available, but to make it full screen, just utilize these black spaces on either side of the monitor. Just you have to do some extra step, and you can do it, get the solution by googling. So that's it for the installation part of Ubuntu operating system. Right, so now we have the installed operating system. So this is the actual instance. So this is the operating system, right? This is the operating system. This is the Ubuntu Desktop. Now I'm going to explain you the components of the Ubuntu Desktop. This part, this is what you call the launcher. This is similar to what you have this is similar to the taskbar that you have in your Windows operating system. This is called the launcher, right? And this is called the menu bar. The menu bar. So even in Windows, at the bottom right, you have the amount of remaining battery percentage, the sound settings, the wireless settings, and settings like that are available at the bottom right of your Windows operating system. So that is available in this top right of window of your Ubuntu operating system. Right, you can set the volume here. Right, internet settings and set stuff like that, and even direct settings are also available there. So this is like the control panel or the settings menu of Windows 10. You can configure all the settings here. So yeah, this is the launcher, this is the menu bar, and this is the wallpaper. Okay, then in Windows 10 you have this computer. In Windows 10 you have computer. You have this Windows Explorer or computer. Sometimes it's called computer or the Windows Explorer, just like this one, where you can access the hard drives. Right, you can access the hard drives. So this is the file manager basically. In Windows we call it Windows Explorer or compute. There is this icon known with the label computer, and so this is your basically file manager. This is the Ubuntu file manager, and there is desktop, documents, downloads, music, pictures, other stuff like that. And if you have more hard disk drives, they will appear here. Right, they will appear here. Okay, and in this file manager, actually this is called the menu bar. This one, this is the menu bar. This is the menu bar, and this is the title bar. Again, this becomes the title bar here because you have the title here. And then these are the commonly used locations, desktop, home, downloads, and everything. And then files and folders in the current browsing location will appear here. So in this documents folder we have a file called doc.jpg, so it will appear here. Right, uh, you can just double click on the file to open the file. So the file will open up. You can also create a new directory by right clicking and clicking new folder or shift control N. So this will be test folder, and the folder will be created. Right, or even if you want to rename it, just right click the folder, just like Windows. renamed folder, or click or type F2. The function F2 button will bring this up, and then you can even copy and cut. In Windows also you have copy paste cut, no? So just like that you can copy, cut, do stuff like that. Just copy and you can paste here. You can even move it to trash, right? Or you can even also use this default copy paste symbols you use. Control C for copying, Control V for pasting, and Control X for cutting. Say Control X for cutting, Control C for copying. Okay. And then there is something called Ubuntu Terminal. So even in Windows you have this black window, usually the black window called command prompt, right? Similar to that, in Ubuntu we have the terminal. You can just, so this is this square is like the start button in Windows, so you can just click it and the set of installed applications will appear. You can type terminal, so the terminal will appear here. Or else, since we have not installed many softwares here, the terminal will appear here at the top in front. So just click terminal, so the terminal will come up. Or else actually you can use the shortcut Control Alt T, and again the terminal will come up, right? This is the terminal. මේක අර command prompt එක වගේම තමයි Windows වල තියෙන. This is the terminal of Windows, terminal of Ubuntu. So there are several commands that you should be familiar with. In the examination you might be asked about these commands, so just be familiar with what is given in the note. So I'm only going through the commands given in your VLE note, and I'll go through one by one. Okay, the first command is pwd, that is present working directory, right? So that is what pw stands for, present working directory. Once you type pwd, it will show you the present working directory. Now this terminal is working on this home/test instance folder, right? Home/test instance folder, right? Now if I want to see what is inside this folder, what is inside this home/test instance, I'm going to minimize this. So I want to see what is inside this home/test instance folder. So for that I'm going to write ls. Ls stands for list, I think. So ls will type list the available folders inside this present working folder. Now I want to go inside this one, right? I want to go inside the documents folder. What I'm going to do is I'm going to type cd, that is change directory, cd space documents. Now I'm inside the documents folder. Now if you type pwd, that is present working directory, it will say home/test instance/documents, because we are inside the documents directory. Now if you want to go back to the home/test instance folder, what you have to do is change directory, that is cd, and just type double dots. It will take you back to the previous or the one directory up, one level up. Now if you type pwd, it will be home/test instance. Now if you want to go to the downloads folder, just type cd space downloads. Now you are in the downloads folder. If you type ls, there is only one file. And then if you want to go back to the previous folder, just cd change directory space double dots, and now you are back in home/test instance. If you want to go to the root directory, right? Root directory, that means the root කෙලවරටම යන්න ඕන. cd space // right? Now you are in the root directory. Now see, now you are in the root directory, that is the root කෙලවරේ මත file system එකේ කෙලවර. Right now in the root directory you have several Linux specific files, and usually now if I want to go back to where I was initially, I will type cd space home, that is now you are in the homes directory, and I'm going to type ls to see what is inside this one. So there is this test instance folder, so I'm going to type cd space test instance. Now I'm in the test instance folder. What you should remember is that these commands are case sensitive. That means now in this test instance folder you have these subfolders: desktop, documents, downloads, music, pictures, public, templates, and videos. Now say if I want to go to documents folder again, what I have to type is I have to type change directory space documents. Now there is no problem. Now my present working directory is test instance slash documents. Now I'm going to go back to the previous directory. Now my present working directory will be home slash test instance. Now if I type like this cd space documents, look, I have typed simple d here. See, it gives an error, no such file or directory, because it cannot find any directory known as documents with simple d at the front. It is case sensitive because you have to specifically or be specific when you type the commands. Now if you type capital D, yeah, it will work, but if you type just this one, no, it won't work, right? Okay, now I'm going to go to documents folder. Okay, now in the documents folder, if you type list, you can find. No, so this is the documents folder now. In the documents folder, there are two files. One is doc.jpg and the renamed folder, doc.jpg and the renamed folder. So those two are available or listed here. Right now, with this command line, we can create files and folders. Right. I'm going to first teach you how to create a folder. In order to create a folder, you have to write mkdir. Mkdir. That means make directory. Make directory. So mkdir and space, type the name of the directory that you wish to name it. Now I'm going to name it new folder. See, a new folder gets created. A new folder gets created. Now I want to create another folder. I'm going to type make dir space another folder. See, another folder was created. Now what happens like this if you do this? Folder 2. So see what happened there. I'm going to just delete this one. Right. What I do is I'm going to type mkdir. I want to name it folder 2 or like this. I'm going to name it folder 2. Look, see here you have a space here. So I'm going to type it folder 2. So I'm making this mistake purposely just to show you how it works. I want to type folder 2. So I want its name to be folder 2. Right. If I do this, it creates two folders. It creates two folders. It considers each term separated by spaces as a single word and creates separate folders for each of these terms. Right. Now what should I do if I want to create a folder like this? Say if I want to create a folder 2. So this is the folder. This is the name I should give to a folder. When I'm creating a folder using the command line, using the terminal. So what should I do? You should do is mkdir and write inverted commas. Start inverted commas and I'm going to write folder 2 now and close the inverted commas. Now our requirement is satisfied. Folder 2 is created. Okay. Okay, now another important one is I want to create a folder and another folder inside that folder, right? It's like this. So now I have folder 2 and then inside that I have another folder called test. Now I want to do this using command line without using the Linux interface. I'm going to use this or do this using the terminal. Okay, so I'm going to do this. You can do this mkdir and these are called switches. Just write hyphen and p. I think it stands for path. I'm not sure what the switch is. So mkdir space hyphen p, and now right I'm going to do is folder 2 slash test. I think even without inverted commas it will work. So now folder 2 was created and inside that the test folder was created. So you can go ahead, uh, test2. So folder 2 is created and it's inside that for test is created and inside that test2 is created. So you can go on like that. Okay, so I think that sums up the make directory or mkdir one thing. mkdir, if you want to create two directories with multiple words like this folder 2 and you want to create another folder called folder 3. So this is how you do it, right? Folders with multiple words, folders having multiple words. Okay, and then I already told you about this ls command. So ls command lists the available files or folders inside the present working directory. Now what we can do is we can move files, right? We can move files and folders. Now I'm going to create a folder mkdir dog folder, right? I want to move this dog file to this one. So what we usually do is we cut it and we paste here, right? So that is the usual procedure, but I want to do it using the terminal. So if I want to do it using the terminal, now here there is no file. What you do is mv stands I think for move. It should stand for move the name of the file which you are going to move. The name of the file is doc.jpg and space the destination. I'm going to move it to doc folder. See, the file got moved to the doc folder. Now the file is there. Now if you want to bring it back, what I'm going to do is I'm going to change directory to doc folder. Now my present working directory is doc folder and here we have the doc.jpg. I want to move it back to the previous folder. So I'm going to write what I'm going to write is I'm going to mv move doc.jpg to the previous folder. So to denote the previous folder, what you have to do is double dot forward slash. See, the file got moved to this parent or the pre or the folder with the previous level. Okay, okay. Then now we can delete folders and files. Okay. So now in this doc folder there is a file and then outside that also we have two files. I'm going to remove this doc2.jpg. You can do is what you can do is you can type rm stands for remove and just type the name doc2.jpg. I think you might have to. I'm inside the dog folder. See, I'm inside the dog folder. Look at present working directory. See, I'm inside the dog folder. I want to get back to the previous folder, that is this folder. So I'm going to type cd change directory double dot. So now I am inside the documents folder. Documents folder. Now there is a file called doc2. So I'm going to try. I want to delete this doc2.jpg. So I will type rm space doc2.jpg. See, it got deleted. It got removed. Okay, now if I want to delete this particular directory and its all content, what I can do is I can write rmdir, that is remove directory, and type dog folder. Fail to remove dog folder directory not empty. That's a question. If I just type this one, okay, it's a directory, yeah. Fail to remove dog folder. Okay, if there are files inside this folder, actually in the note, in your note, they have given, what they have given is rmdir delete a whole folder. Rmdir, that is rmdir delete a whole folder. If I just type this one according to your note, it should delete the it should delete the directory with all its content. So that is given according to your note, but apparently it does not happen like that. So in order to delete a non-empty directory, that is a directory that contains files inside it, you have to write rm and type another switch rf, right, and now type log folder. Now it got deleted, right? So this switch has to be entered. These are called switches. R and F are switches, right? So R stands for, if you, so now actually each of these switches represent a meaning. So in this case, R stands for, or it gives, or you give it the instruction to remove directories and their contents recursively, right? That means if you have multiple folders or files inside a particular folder, just recursively go through each and every folder and delete all of them, right? And F stands for no, ignore non-existent files, never prompt. Ignore non-existent files, never prompt. I will add a link which you can refer, and I will add the link in this chat. Just go through that, save it or go through that, or you can just do a Google search and it'll come up. Okay. So that is how you delete a folder and its content or folder. So basically we learned so far, so this is the note. This is the note. We have learned how to install Ubuntu in a VirtualBox, and we learned how to install Ubuntu as the primary OS. So that is what we did with the VirtualBox, and we installed Ubuntu with another OS. So those are the things that you can, these are the things which we discussed, and I I just taught you about how to install Ubuntu in a VirtualBox, and if you are going to install Ubuntu as the primary OS, or dual boot it in your computer directly without the use of a VirtualBox, please be careful with your data. Okay, if you follow a good thorough tutorial, then there won't possibly be any issues. But again, please be careful when you are doing partitioning, and there, if you do not do it right, there is a risk of losing data. So that is why I'm telling it repeatedly. Just do it right. If you are doing it right, there won't be any issues. But make sure that you have covered yourself in that area before now installing the stuff. It's not a huge thing. Just you have to just create a separate partition or separate unallocated space for Ubuntu in your computer hard disk, and then it'll do the other stuff itself. But you have to do the partitioning, and giving it unallocated space, and you have to do it right. Yeah. So, and then we understood the components of the Ubuntu desktop, and then we played with the file manager in Ubuntu, and finally we worked with the command line in Ubuntu, where we opened the terminal and we created folders, and then also we moved and manipulated files and folders. One thing which I did not cover is, and it is also not covered in your note also, but I'm going to explain it. You can create you know empty files here. Now see, you want to create a text file, just type touch, okay, touch, just type the file name test.txt, and it will create a text file here. It will create an empty text file here. Now imagine you want to create a file with some text. What you can do is you can type cat, this greater than or less than symbol, and type the file name. So let's say cat.txt. Now it will give you an interface in which you can type the text. So type, say, cat1, cat2, cat3, free and open source software for personal computing, IT 1306. So these are line by line statements. I'm going to just click type Control D now. Finally type Control plus D, right? Now if you open this, see, what you typed is available here now. What you typed is available here now. Cat1, cat2, these are the things you typed here, and they are available now. Okay. Now if you want to make any changes to an existing file without making without overwriting the content inside the file, you can do is just type cat and double less than symbol, now the file name cat.txt. Now it gives you another interface. So I am typing again, uh, sorry, I am typing again. This is a new line, this is a new line. These changes get appended to the previous file. Okay, so I'm going to now type Control D. You type Control D twice apparently. Now double click it. See, we previously stopped here. Actually. Now it has appended all what I typed to this one, to the existing file. So that is basically how you can manipulate or create and edit the existing files or create new text files. So those are the things that you will be asked. or possibly ask. I'm not sure what they will be asking you. And at the end of your note, actually, there's an activity which you can follow. Create the following folder structure using commands in a terminal. Just follow these instructions and get yourself familiar with an Ubuntu operating system by doing this little exercise, and then you'll be good to go. And I recommend you to go through this note again. So this is available in your virtual learning environment, and as I said, please go through this note again, and you'll be able to grasp the concepts and understand the basic requirements which are required for working with Linux operating system and Ubuntu operating system and Linux operating system all together. So just follow this example, and I think your examinations will be held in next month, and uh, for other sessions or other lessons within this subject, I have already covered them in terms of either online sessions or in class sessions. So if you have any question, please obviously raise them in the WhatsApp group. And yes, and also please in previous years this subject was not considered for your GPA. Your grade point average was for you are calculating your grade point average. This subject was not considered in previous years, but from this year onwards, this is not an enhancement course. That is, you have to give your best when facing this examination, since the result of this subject will be considered for calculating your GPA. So I'm reiterating it again. Do your best for this examination. Just don't අතාරින්න එපා, මේක නිකන් ගණන් ගන්න තු ඉන්න එපා. අනිවාර්යෙන් මේක හොඳට කරන්න. ඔක්කොම ටික කන්ටෙන්ට් ටික බලා ගන්න, ඔක්කොම කරන්න මේ GPA එකට calculate වෙන නිසා. Okay, so that's it for today's session, and since the examinations are coming up soon, I would like to wish you all the best, and please go through all the subjects, and since this will be your first examination, do it well. All the best, and stay safe. I don't know how they are going to conduct the examination, but keep the distance and follow the safety standards or safety regulations given by the health authorities. So keep yourself safe. So that will be the most important thing. And yes, I would like to again wish you all the best. Thank you very much for participating in this session. Good night. Has anyone got any question? Okay, you're welcome. I think the silence indicates that there are no questions. So obviously, if you have any questions, just add them in the WhatsApp group, or just directly message me over WhatsApp, or whatever the way that you prefer. Okay. Thank you very much. Good night then.